Hello and welcome to CS201 Walkthroughs. My name is Ansel and today I'm going to be doing a brief overview introduction to Unix and to the zoo. There's already a lot of guides and stuff on this topic, a lot of which are specifically about how to submit your homework for CS201. So I'll link to a bunch of resources in the description that I think are useful that you should probably investigate. And for those of you who are seeing Unix and using the command line for the first time, I'll link to some longer videos that might help you get used to sort of the interface and just get used to what's going on. But the structure of this video will basically be I'll walk you through submitting your homework through the different tools that you can do. I'll also sort of talk you through how to use the shell and the command line as we go, and at the end there will be some bonuses. I'll show you how to save your passwords that you don't have to enter it every time you do SSH, and some other slightly more complicated life hacks, streamlining things that you can do to save time. I'll also show you how to set up Windows to use Unix because it doesn't by default. So to get started, Unix is at the heart of Mac OS and Linux operating systems. It's just a bunch of code. It's, for our purposes, a file system and a set of tools for interacting with that file system. So things like moving files, renaming them, deleting them. Yeah, that's about it. The zoo is a set of physical computers located in Yale. Some of them are in AKW and some of them are in Hill House. If you walk over there, you can use one of them, just like your computer. They have keyboards and monitors. You can also log into them over a network through your shell, which is what we'll be doing. And then you can interact with them just like you would interact with your own computer through the shell. You can see the file system, you can modify files and things like that. And you'll need to do that to submit your homework. So what is a shell? A shell is kind of like a text-based user interface. If you ever used a REPL for a Python or any other programming language to kind of type a line of code, hit enter, it'll run the line of code and give you back some result. That's basically what happens with a shell. There are some different shells. One of them is called fish. They basically do the same thing. They have some programs of their own. They also just let you use some programs that are built into Unix. They also let applications interact with each other. Those are just some of the many uses of a shell. But you can't just open a shell on your computer. You're going to need an application to sort of see the shell with. So a terminal emulator is basically just that. Mostly all it lets you do is use a shell. So you can type things into it and run commands, things like that. These are some terminal emulators that I would recommend for these respective platforms, and Alacrity is what I'll be using today, and it's cross-platform, but it's a little harder to set up. I'll also, at the end of this video, put a link to a GitHub repo, I think, with some of my configuration files, so if you are enticed by the visual aesthetics of any of the setups that I have today, you can copy them or see how I did it. So for now, I'm just going to move over to my terminal and we'll get started. Okay, so I've opened my terminal emulator, and now hopefully you should be seeing something similar to what I'm seeing now. This on this side is just the shell prompt. It will display some information about maybe your username, what directory you're in. Remember, what we're looking at here is just a file system. So we're in a folder, just like you would be in Finder or File Explorer on Mac or Windows. And if we type this command and hit enter, we can see all the files that are in this folder. And if we type pwd and hit enter, we can see what the folder is. So the Unix file system is organized like a tree. There's a really nice introduction breakdown of this on the CS201 website, actually, which you'll probably have to read anyway if you haven't already. So I'll leave a link to that to the description if you want to look at it right now. But basically, you have the names of folders. If they're nested inside each other, you're going to have a folder and then another folder that's inside of it. This one slash represents your root directory. So if I type cd, that stands for change directory, and then this one slash, and hit enter, then I'm going to be in my root directory. So this is the top level directory for my system. There's nothing above this. And if you just type cd without any arguments, just cd and then hit enter, you'll go to your home directory. And like you saw before, that's in your root directory /home/ your username. And that's pretty standard for most Unix systems. So some other brief commands that are useful. ls, again, prints out the files that are in your directory. So you can see this folder is showing up in a different color. And this one file here that I have is also displayed. The basic structure of a Unix command is you'll have the name of the command, then you'll have some optional arguments. So for ls, you can provide some arguments after this dash, and most other commands are similar. So this L argument will display these items that I already saw in a list. It'll just look a little bit different. You can see some file permissions on this side, like a date accessed, file size. If you do ls-la, A shows hidden files. So there's some files, if they start with a dot, that are hidden on your system. There's a ton of configuration files in your home folder, which is why there's so many more items when I do -a than just ls, but you can see here the other two folders that were already here. So I'm just going to type Control-L, and that's going to clear my screen. The other useful commands that you'll need to know are networking commands. So you're going to need to access the zoo somehow, right? Remember I said before we can log into the zoo basically through this shell, and then I'll see a very similar looking shell, but the file system will be the physical computers in Hill House and AKW on the zoo computers, and I'll be able to navigate those and upload my files to there. So to upload files from one computer to another over using the shell, you're going to use this scp command. It stands for secure copy. And what you'll need to do is you'll need your host name. So for me, that's going to be my net ID, like this, then the @ symbol, and then this this big block of text right here. So node.zoo.cs.yale.edu. It's kind of like a link or like a website. So this is your username on the zoo. You should already automatically be like set up as a user on the zoo because you're enrolled in this course. So it's your username at the host name, which is the name of the computer that you're connecting to. And then, yeah, so ignore all the light gray text. That is just like an auto-complete thing that I have installed. So if you type this command in, it says usage, scp, blah, 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 blah. That means I typed it in wrong. So I missed something. And if you think about it, this is a copy command, but I didn't give it a file that I wanted to copy over. So instead, what I'm going to do, remember, if I ls'd, I have this racket homework file here. What you're going to want to do is, remember I showed you the cd command before? You're going to cd into whatever folder you have your homework in. So probably you can type cd once to get into your home folder, then cd, maybe your homework is in like documents. If you go into documents, there's like probably some like school folder that you have. You're going to keep cding until you get to the folder that contains your homework file, and remember what it's called. And then you're going to run this command, which is scp, the name of your file, and then that host name from before. So remember, it's your username at node.cs.zoo.yale.edu. And if you type that in and don't make any typos, you should hopefully get nothing. It might give you like a little loading bar. That's what it usually does. Oh, you know what? I think I typed this command in wrong. So this is like a major, point of confusion. So when you copy this file over to the zoo, not only do you have to tell it which user on which computer you're going to, but you also have to tell it where in the file system on that computer. So the way you do that is you're gonna have another like delimiter. So you have your username, then this @ symbol separates the host name, then this colon separates the directory. So remember, tilde here just stands for your home directory. It's just a shortcut. So if you put the tilde afterwards, it'll go to your home directory on the zoo. Could not resolve hostname node.cs. So what I did is I accidentally switched CS and zoo. As you can tell, this is not easy to remember, but I promise you eventually you will. Okay, great. It looks like it worked. You can see homework0.rkt 100%. That's the speed it was uploaded at. That's the file size. Cool. So we've sent our file off to the zoo, but where did it go? I can't access it anymore from the shell because I'm still on my computer and the file is on the zoo computer. Actually, it's still here as well because that was a copy command. It's not just I didn't just move it there. I made a copy of it and sent it there. But, and it looks like I accidentally might have created this directory too. Okay, well, to remove something you can do rm and the file name, and then this is my host. It made a file basically with my host name. So anyway, I'm gonna remove it. You can see that I LS'd again and it's not there. So how do I get to the zoo? Well, that's simple. I just need to type ssh-zoo. For me, I can do this and it will work because I have this zoo set up to like automatically expand to this whole long string, which I'll show you how to do later. But for you, you're gonna need to type ssh your net ID at the same thing, node.zoo.cs.el.edu. And once you do that, you should be prompted to enter your password. And then probably you'll be prompted for two-factor authentication with Duo, and you'll need to type push for your second password, and then you'll have to answer it on your phone. I'll show you how to bypass that in a second. So for now, you can see the prompt has changed. I'm going to hit Control-L again to clear my screen. It looks slightly different now. I'm now in a zoo node, but basically all that means is I'm on the zoo computer. So if I type ls, you can see that the files are different. I'm in an entirely new file system. I can do whatever I want to these files. I'm under my own user at the zoo. So whatever I do isn't going to interfere with other users on this computer. You can see my home directory is under home/account/ab3254, but if I were to list home/accounts, I've basically just doxed the entirety of Yale University, and you can see all of the net IDs. So everybody has their own account. You can't interfere with files in other people's accounts because of file permissions. So go ahead and do whatever you want. You're not going to break anything. But be careful with your own files because you might accidentally delete them, and that would be bad. So what do you do now that you have your file uploaded to the zoo? You're going to need to submit it. So if I ls again, you can see that file that I scp'd. Remember, I sent it to the home directory of my zoo account. It's here. If you are enrolled in CS201 on Canvas, you should automatically have this directory for you, this CS201 directory. You might have some other stuff too. Probably not as much as I have here. If you don't have the CS201 directory, you're going to need to reach out to us. We'll help you fix the problem, but post something on, probably send an email to the CS201 help email. Before you do that, if you want, you can try this command, sudo register CS201. Remember, only do this if you don't see the CS201 folder. You can run this command. It'll prompt you for your password, and then hopefully you'll see this folder. For now, I am just going to move my homework 0 file into my CS201 folder just to stay organized using this command, mv, and then I'll type the name of the file. You can hit tab on bash. That's the shell, remember, for auto-completion usually. Just hit tab and it will finish typing what you're in the middle of. So, and then I give it the destination folder. So I'm going to move this file into this folder. Now if I ls again, you can see that that file disappeared. It's different from the copy that I did earlier. Remember, SCP is to copy things over the internet. There's also just regular CP, which is if you're on the same computer, you can copy a file into a folder. Basically, with MV though, I just moved that file into the CS201 folder. So if I cd CS201, you can see it changed. I'm in CS201 now. If I ls again, you should see this homework 0 file. There's also all of the other homework files in here. That's because I already took this course. You can ignore that. Yours should probably be empty. So what I'm going to do now, I'm going to submit my homework. Remember, just because I copied it over to the zoo computer does not mean it's submitted. To submit, you're going to have to run a command on the zoo computer. So just like ls or cd or any of these other commands, the submit command has a very similar syntax. So this is the command to submit your homework, /c/201/bin/submit. And basically what it is remember when I was talking about shells before and how they're kind of a programming language, you can write a shell script, which is just a list of a bunch of shell commands that looks kind of like code, and you can save it as a file, and then you can execute that file with some arguments, again, just like the other commands that we've been seeing. And so that's what the submit command is. It's just some code that one of the professors wrote that will take your homework, probably grade it, move it to some other directory. I don't know exactly what goes on inside there, but this is what you're going to need to do in order to actually get a grade. So the arguments to the submit command are the assignment number, so 0 for homework 0, and then the file name. So I want to submit homework0.rkt. If you had other files to submit for this assignment, like I'm pretty sure you're going to need to submit this response.pdf file to. At least that was the way it was when I took the course. You'll have to add that. You can add any number of files. So once I do this, well, okay, there's a good chance for me that it's not going to work because I'm not a student in the class like you are, but hopefully you'll see a positive message saying something like you've submitted it, blah, blah, blah. If it doesn't work like this and you're hung in the terminal emulator and you can't do anything, and your arrow keys just make weird like symbols, anytime you're stuck in the terminal, you can just hit Control-C and that will stop whatever's going on and like reset it. And if you hit Control-C a couple more times, you can see it just gives me a new prompt. You can also use, just another quick tip, you can use your arrow keys to access the most recent commands that you've run. So if you hit up arrow a bunch of times, it'll cycle through your most recent commands, and then if you hit down arrow, it'll go back to where you were before. So yeah, Control-C, your arrow keys, the tab key for autocomplete, all very useful. Anyway, if you've submitted your homework successfully, unlike me, and you want to check that you did submit it, in fact, you can run this this other command, also in the /c/201/bin. It's called check. You just check and you add the assignment number. Don't forget the assignment number. If you guys are wondering where I got all these commands from, or if you want a list of them, as well as some information about what they do, I'm going to put a link to a page on the course website that includes all that information, so you guys can look at it later. And there's some other commands like unsubmit, so if you accidentally submit the wrong file, you can do /c/2CS201/bin/unsubmit 0, and then I think you probably need the file name as well, and then that should like take it out of your submission folder. Usually, I think you shouldn't need to run this command. You can just submit the same file again and it will overwrite it, but okay, here I finally got some feedback even though it looks like it's an error message. But that doesn't matter. So basically that is hopefully all that you need to know in order to submit your homework. One other useful thing that you can do while you're here on the zoo is run the autograder. So when you start doing your homeworks, you'll notice that there's some tests built into the racket file. So when you run the racket file, it will run some tests on your code. there's another way that you can test your code, and for some of the assignments later on, it will actually be necessary to test your code using the autograder as opposed to the built-in tests in the file. So if you want to run these tests, I'll show you how to do that now. It's a similar command. You run cs/cs21/bin/autograde. For this command, you need to be in the file where in the folder where your homework files are located. So if you have uploaded all your homework folders to the CS201 directory on your zoo page, make sure you cd into that before you run this command. Autograde, you're going to need the assignment number, because you don't need to pass it. I don't think you need to pass it the racket file. I think it automatically looks for a racket file with the correct homework assignment. So all you need to pass it is the assignment number that you want autograded, and and you can also pass it the problem. So if I wanted to grade homework 0 problem 1, I would just do 0 space 1 like this. It looks like I forgot something. It says usage autograde --test. So let me go back here and add that as a flag. Okay, great. So I think my homework 0 file, yeah, it's working. So I'm passing these tests. If I scroll back up a little bit, I can see this is where I ran the command. Here's the output. So I'm passing all of these test cases. It looks like these might be the same test cases as were in the assignment. But like I said, this will be useful later on. You can see all of these test cases are passing. That's because I submitted this homework like 2 years ago or whatever. Anyway, I think that's all I'm going to show you about the zoo for now. The last thing I will say is to get off the zoo. You could just close your window, but if you wanted to go back to your computer, you can type exit like this to leave the zoo and hit enter. You can also just type Control-D, and that's going to let you quit your remote connection. So yeah. You've probably realized that it's mildly annoying to log into the zoo and have to like enter your password and then have your phone and then all of this stuff every single time you want to copy a file over or log into the zoo. So this is the fun part where I get to show you how I make my life easier through some pretty simple config files, and also show you some cool things about terminals and shells in the process. So the first thing that I would recommend for everyone, because this is really easy to do, is that you make an alias for zoo. That means that every time you log in, you won't have to type in your entire username at node.zoo.cs.yale.edu. You won't have to remember that. What you can do instead is make a file somewhere in your home directory. It probably already exists. It's probably under a folder called .ssh. And you can put some settings in that file that will allow you to take advantage of this. First what you're going to do is, if I ls-la, remember, in my home directory, I can see all of these folders. And so the one I'm looking for is .ssh. There are probably some tutorials for this online. If I find one, I'll link to it in the description, in case you run into some errors, like maybe this folder doesn't exist, and stuff like that along the way. So right now I'm just going to cd into this folder. So cd, change directory, remember, .ssh. If I ls again, I see that there's a bunch of files in here. Probably I have some more files in here than you do because I've already configured this other thing. This allows me to save my password. But right now what we're going to look at is this config file. So one of the cool things about the terminal is that you can actually edit files from within the terminal. So there's some programs, one of them's called Vim, and you can use that to like write in files and save them inside of your terminal. It might seem unnecessarily complicated, it probably is. The only time that it's really useful is if you wanted to edit files directly on the zoo computer. Now you can do that in some like development environments like VS Code, what a lot of developers use to write code. You won't use it for this class probably. You'll probably be using Dr. Racket to write Racket programs, but it's just useful to know that that you have these tools available to you. So I'm going to use a program called nvim to edit this file. But for most of you, you can probably write open. If you write open config, it should open it using whatever like system text editor you have set as your default, and then you can edit it in there, and then just make sure you save it at the end. But for now, I'm gonna edit this config file, and yeah, so you can see I already have some stuff in here. Yours might be empty. If it doesn't exist, again, you're gonna have to make it. I'll show you how to do that from the terminal in a second, but hopefully you'll find a tutorial that explains it for you too. So you're gonna want to make an entry like this, this second one that I have here. You can see it says host zoo. This is whatever short word that you want to replace all of this with. So you're gonna need to copy this exactly. You'll have host zoo, host name. Make sure you pay attention to capitalization, that matters for these kind of config files. And here you can put node.zoo.cs.yale.edu. I'd have Ladybug just listed as a specific node for no particular reason, other than I like ladybugs. You'll need your user as your net ID. And then these two are optional. If you Google them, you can figure out what they do. Mostly they help me if I'm in the zoo for a long period of time. They help me not get kicked out just by timing out. So yeah, if you add a block like this and then you save your config file, you should be able to just ssh zoo like I did before, and yeah, you can avoid remembering that whole long string of text. To make a file, so if your config file hasn't been made, this is just another shell command. You can use something called touch, and so you would write touch config, and then it would just create an empty config file, and then you could fill it up like I showed you before. So for now, I'm just going to cd back to my home directory, Control L. Okay, and next I'm going to talk about something called ssh-agent, which will help you save your passwords. Okay, so we're getting pretty deep into the weeds here, but if you're like me, you're probably not satisfied with just being able to type zoo to go into the zoo. You probably also don't want to have to submit your password every time. So this is the part where you can thwart the system and use SSH keys instead of a password to log into the zoo extra fast. So I would really only recommend doing this if you have a little bit of experience already with the shell. If you already knew what you were doing before, you didn't have to watch the first part of this video. Maybe you've customized your bash RC a little bit, or you've at least opened it. If you don't know what that is, I would look it up and maybe read this article thoroughly before you get started. So I'm probably not going to do this, but I'll give you a brief overview of what it's doing. Basically, you're not just forfeiting your password, you're going to generate a secure private key that gets stored on your computer, then you're going to upload a public key to the zoo, and then they'll be able to communicate to each other and verify that it is indeed you logging in from your computer, your laptop, and so you won't have to submit your password every time you log into the zoo. The only way that this is unsafe, it's not like somebody can just access your zoo account from a random computer, because they won't have the private key on that computer. The only way that this could go bad is if somebody physically steals your laptop, knows your login, logs in as you, and then proceeds to log into the zoo and submit your homework for this course, and they do it badly. That is truly the worst case scenario. So to do this, first you're going to run this ssh-keygen command. You can hit enter a bunch of times to use the default settings and leave this passphrase empty. You could put a less complicated passphrase here if you wanted, but you will have to enter this every time. I just left mine blank. Next, you're going to run this ssh copy ID command. Name of remote server, that's your username at zoo, or just zoo if you did the last step. Then it will copy your public key over to the zoo. I guess there's a prompt here, type yes. Then you'll need to enter your normal logging into the zoo password so that they can SCP your key over. This is just a a tool to basically copy your public key over to Z for you. Then it will ask you to log into the remote server to verify that you don't have to enter your password. And if you do that and you don't, then it's fantastic and it worked. There is, unfortunately, a slightly deeper layer to this, because in order for ssh-agent to work, it has to be running. So the way that you get away with this key generation thing is that there's this program running in the background of your computer. If you want to understand it, again, I would recommend just read this article. But it doesn't start automatically when you launch your shell. And you probably don't want it to for security reasons. So to get around that, there's a program called ssh-ident, written by the author of this article as well, that's on GitHub, a fairly popular program for making sure that there's an SSH agent running whenever you want to SSH somewhere, and basically that will make it so that you never have to worry about SSH agents being left running in the background after you leave your terminal session. It's just an extra layer of security. And it is also kind of necessary if you don't want to have to start an SSH agent each time you open a new terminal window. So there's installation instructions here. I won't go through it. If you've gotten to this point, you probably already know what you're doing. Briefly, I would recommend this method. So if you're going to install ssh-ident, you're going to have to download this file from the GitHub so you can open it and then save it to your computer, put it in like your ssh config directory, and then you're going to probably want to make this alias in your .bashrc file. So you open your .bashrc file, add this line. That will kind of overwrite the default ssh command to run this script, which will then call the default ssh command only after it starts an ssh agent. And then if you want to use scp, there's an alias in here for that too. What you'll have to do is add this line down here, and make sure you replace this path to ssh-ident with your actual path. So that's it. I'm not going to go through actually installing it, because I believe if I have to walk you through it, then you probably shouldn't be doing it. Yeah, so next I'm going to talk about setting up WSL on Windows so that you can run Unix from Windows, and I'm going to make that section a little bit easier to follow so that anybody can do it, because I know there's a lot of you out there on Windows laptops that also need to be able to use Unix, and yeah. Okay, last but not least, this one is for those of you who are taking this course on a Windows machine and still want to be able to play with Unix and submit your homework, but aren't sure what to do. So what I would heavily recommend for you guys is to make is to follow this article on the Microsoft website. It's for setting up a WSL, that's Windows Subsystem for Linux development environment, and all it's doing is installing a virtual machine on your Windows machine so that you can run a very small operating system, a very small Linux operating system on your machine, and then you have access to all of the Unix commands that I was talking about before. In order to do this, there is a lot of documentation already. One of the videos that I've already linked to, the Linux tutorial video, has a whole section on WSL, so I will put a link to that and timestamp. It's at around 20 minutes into the video in the description so that you guys can follow along there. But if that doesn't do it for you, or if there's a newer tutorial out there on YouTube, I'll look around really quickly, but I know that there's a lot of documentation for this. And again, if you have any questions, please just reach out to the CS 201 help email address or post on discussions. I think there's other ways to use SSH from Windows. You can use some programs called PuTTY. There's some other programs that basically allow you to SSH from the Windows PowerShell, which is the kind of equivalent to a shell for Windows. The thing about the PowerShell is it doesn't have the same commands. It has similar commands, but they're different, and there's some discrepancies like backslashes instead of slashes for directories. And it's also just not what you're going to be learning in this course. So I wouldn't recommend learning the PowerShell. Instead, I would recommend installing WSL, or alternatively, installing an SSH client for Windows and then logging onto the zoo right away, and then you'll be in Linux and in a Unix-based operating system on the zoo, and you can practice Unix commands on there. But to install WSL, I will link to this article. I'll link to some video tutorials to help you out. And once you do that, the virtual environment runs on the same file system as your Windows computer. So if you run Dr. Racket from Windows and you save your files in your documents folder, you'll still be able to access that from WSL. You'll just have to CD a couple directories deeper, because the Linux file system will include all of the Windows file system that's there already. But again, if you have any questions about that, please ask or come to office hours. We'll be super willing to help you, and there's lots of documentation online. And I think this article is pretty easy to follow. I've done it myself. So yeah, that's basically all I had to say. I hope that this video was helpful for you getting up and running and explaining enough about Linux and Unix for different levels of experience, and I hope that you found something useful in it.